This is Honors Algebra 2 Pre-Calculus. We're doing 10.6 in Pre-Calc, which is parametric equations. So sometimes, especially in physics, we want to define motion in respect to time in multiple directions. So we do this by using a thing called parametric equations, where the position in each direction is given in terms of the parameter t, which would be our time. So x of t, meaning an x function written in terms of t stuff, so x equals a bunch of t stuff, would be the horizontal position, meaning left or right position, at a time t, and y of t would be the vertical position, meaning up and down at time t. Now, in higher level real-world applications, you might also see like a z of t for forward and backward motion, meaning like in and out of our whiteboard, right? So again, horizontal, x of t, vertical, y of t, but if I want to talk about coming in and out of the whiteboard, like coming off of the whiteboard, that would be something like z of t. Now, we're only going to deal with 2 dimensions here. Certainly, if you ended up working for like NASA or some aerospace company or became a pilot, you also have to worry about other directions of motion, like things like pitch and yaw, which refer to a sort of a rotation of the spaceship or the plane and other things. Again, that's way past our level, but the point is that parametric equations don't just have to be in 2 dimensions. We're going to deal with them in 2 dimensions, but they can certainly take into account other things. So even when you're talking about like tracking storms and things, you can talk about whether a storm is moving left or like east-west, north-south, or up and down in like the atmosphere, right? So there's definitely 3 directions of motion most of the time. We're only going to deal with 2. So we're going to have a couple big goals when we walk through this this section, right? So the big things I need you to be able to do with parametric equations, right? So here are our goals. There are lots of things that you can eventually do with parametric equations, but right now our goals are, 1, we're going to be able to sketch a graph. Okay, and when I say that, I want us to be able to do it by hand, but I also want to show you how it works on a calculator, just so you know, right? The other big goal that we're going to have in this section is we're going to have the goal to do what we call eliminating the parameter, right? And so essentially what that means is get rid of t, right? So we end up with x's and y's, but no t. Okay, no t, right? 2 separate words. So those are the 2 big goals that we're going to have for parametric equations. Certainly there's lots of other stuff that you can do with parametric equations. I also want to point out that you'll see this in your textbook. So as a side note, the parameter is not always t, right? So the parameter is usually t, right? But sometimes, especially if you see trig functions, so especially if there's trig, it'll be theta, right, for an angle. So just to throw that out there, your parameter doesn't have to be t. It is disproportionately t, but it could be theta. It could be something else. Technically, it could be really any letter that's not x or y, as long as those are the only 2 directions of motion you're dealing with. But traditionally, it is, sorry, my super bothered by the fact that my A looks kind of like an O here. Okay, so usually it's going to be t, occasionally it's going to be theta if you see trig, but that's sort of the gist.